The StateSequencer module has been designed to provide a flexible automated tool for testing. A complete sequence of states can be defined and measurements can be assessed automatically. The StateSequencer's interface has been structured in the same way as the other modules. The table view summarizes all defined states. Use the States tab to create, delete, or navigate between states. You can configure the states in the Detail View window. For example, the Analog Outputs tab allows you to set the voltages and currents in one of the fault calculator set modes. The Binary Outputs tab is used to define which of the binary outputs will be active in a particular state. Remember that this tab will only be visible when the binary outputs are enabled in the hardware configuration. The Trigger tab defines the condition that terminates each state. There are different possibilities: maximum state times, binary trigger conditions, manual user interaction, and external triggers like GPS or iRig-B pulses. Use the Assessment section to define time measurement conditions and evaluate binary conditions during the states. After this introduction, we are ready to build an application example with StateSequencer. For example, we can test the first element of our relay's emergency overcurrent protection function, which is set to 1.8 amps with a time delay of 500 milliseconds. First, we enable three-phase currents and the trip contact in the local hardware configuration. The test object parameters stay the same. The goal is to simulate two fault events just before and just after the boundary of the first element to measure the relay's reaction. It is advisable to draw a workflow containing the states and trigger conditions to be implemented in StateSequencer. Our sequence will be composed of an initial pre-fault state with a timeout of 1 second. This state will be followed by a three-phase fault state at 90% of the first element setting, that is 1.62 amps. The relay is expected not to trip, so the state's termination will be set to a 1 second timeout. Next, we add two additional pre-fault and fault states, but this time the simulated fault will occur at 110% of the set value, that is about 2 amps. The termination of the fault 2 state will be a combination of a binary trigger and a timeout. This means that the next stage will begin as soon as one of these two conditions, whatever occurs first, is fulfilled. This way, we force the module to move on to the next state in case the relay doesn't trip. Finally, we add a post-fault state with no current to finish the sequence. The timeout is set to 1 second. Now, we use the States tab to add 5 states to the table view. The next step is to assign names to each of the states. For example, pre-fault 1, fault 1, pre-fault 2, fault 2, and post-fault. Going to the Detail view, we enter the output values and define the trigger conditions for each state. We start with the pre-fault 1 state. The current to be injected is 0 amps, while the timeout is 1 second. The fault 1 state consists of a three-phase fault with a magnitude of 1.62 amps. The timeout is 1 second. In order not to bore you, we will complete the remaining sequence of states by following the same procedure. Remember to select both the timeout and binary trigger condition in the fault 2 state. Once the binary trigger condition is selected, you need to specify the signal state. The trip signal has been set to 1, which means that the state will terminate if the relay trips. We can use the time assessment table to measure the recorded trip signal during fault 2. The measurement will then start at fault 2 and will end when the trip signal is detected. Since more than one trip may eventually occur during the sequence, the Ignore Before option allows the user to narrow the search by ignoring any event before the state indicated. In this case, we will ignore any trip signal before fault 2. The nominal value is 500 milliseconds with a tolerance of 40 milliseconds. In state assessments, you can define the binary signals which have to be present or not during the states. The tolerances define the time range after the beginning of a state during which the signals are permitted to deviate from the defined conditions. State assessments can be used in this example to check that the relay does not trip during the fault 1 state. Finally, we are ready to run the test and check the measurements. The green crosses indicate that the trip time fulfills the tolerance requirements and that no trip occurred during the fault 1 state. Don't forget to check the Time Signal View window to have a graphic overview of the sequence and the recorded signals. Here, we can confirm that the relay tripped because of the fault generated during the fault 2 state.